Hello, welcome to my MyWebUniversity free educational videos. I'm going to share my screen first so you can see what I'm going to have for you tonight. First, let's share the screen. And as you can see here, I have a number of videos that is already available at my MyWebUniversity free educational videos. And the video that I had previously done was for awk programming language or awk scripting, which you should watch that one. There's a lot of tips and tricks on it. I'm going to just do similar videos, but using a session today, a terminal session here. So I'm currently logged on a Linux Ubuntu server. And in order for me to just demo it, I already list these bash scripts that I have here. So if I just clear my screen and then just say ls -l star.bash, I get this listing. But in order for me to just know, for example, what are these fields and what are each of these columns and field numbers and the ownership and groups and everything, these are called inode number, ls -li. And then the inode structure, it has a inode number, but which is pointing to a data structure, and then data structure basically is giving me statistic on it. So the inode numbers are in the first field, and then read write in this case is there. Based on the command, you can just do awk with it to just print out certain ones. So if I just am interested on this output and say awk, then and say print $1, this would print the first column, which is the inode number. So this would just give me the inode number here. And similarly, if I just print the $8, it would be just those number. $9 would be the next one, and $10 in this case is going to be the file name. So again, if I do ls -l i.bash, ls -l rather than li, notice that number changes. So here, $10 doesn't exist actually. It's actually, it is there. So $10 is still pointing to, oh, because I have li. So if I just do L, that $10 does not have it. But $9 is pointing to the name of the file. So what is that awk is giving us? It's just giving us like a filtration with this piping, so we can just be interested on certain fields here. So if I just say, for example, here, let's just grep out -i. So we're using the grep command with the syntax of -i, meaning ignore case, and then they use the word print. Since this print statement is only used once here, it found that file, and then it printed. Now, if I just do more manipulation of that file, then I could say while read, put into the file name, and then do, and then say echo that file is $file, and then we just do that one, and then if we want to do ls -ld on $file, we could do that. If we want to just get a statistic, we could do a stat on $file, and so on. We could do anything we want to do with it. So I'm going to just say done, and then as you can see here, the ls -l command that I run here, it just gave me this file name only first. Then I used that as a variable, and I used within this do and done, I iterated within the loop for the while statement. So it says the file is, and then it says the file is this, and then ls -ld, and then stat file now. So now if I want to just get the statistic for all of the files in long listing, all I have to do is that change this grep -i command, take it out. I don't need that one. I could do with everything. So now it's going to do it with everything. But because it's so fast, there we could just for the sleep mode, and then just wait for it a few seconds and then do done. So let's just do that. And within this done, we could just say sleep like 3 seconds, and then run the date command. then do another sleep 2 seconds, and then say done. So let's see, right now it is waiting 3 seconds, then it prints out the date, then it does the second one, and then writes another date, and so on. So that's how the shell scripting is going to be easy if you just want to do it within the terminal as you go. But because the list is really huge, we don't need to just wait for all of them. I can Control-C out of it, and I clear my screen, and I show you more example. Here I just do ls-l.bash, and if I just say, okay, I did this command, let's just write this information also to a file. So we could say T is saying that write this file into the t.txt. So this output is printed on the screen, and then this T creates this file as output and this.txt. Whatever was the output that was printed on the screen, at the same time, that file is printed on this file name. The output is written in this file name. So at this time, I could do even here, say cat this.txt, and then do awk print $9. Notice that $9 would be exactly printing those ones. So if I want to just print $0, it is the entire file from that one. You could also do a print without a $. It is assumed as if $0 is given. So whether you do the cat or not, you don't need the cat command. You could just do cat and then, awk and then print, and then do this, and then the name of the file, this.txt. So earlier we were using the example of piping, and now we're just giving the input as file name. And then here you could just still do print $0, which would be the entire file. If I want to just print $3, and that would be wlutfi and root, so that would be those two, and then $4 would also be the honor and group. So $3 would be the honor, and then $4 is the group, and then $9 is the file name. So $9 would be the file name. In this case, I'm writing the ownership, the group in this. If I want to just print $1, that would be the first field, which is read, write, execute permissions for the owner, and then other people's are blocked, except for this file. Root has a read, write, execute open for group and others. So let's just look at one of those examples, like cat print-less.bash. So this script, it actually is a bash script that is just going through to display 1 through max, and then the max is defined, given on the $sign as argument. If the argument is not given, we are going to provide it. So let's just say print less.bash. If you don't provide it, the script should detect it, say that you did not provide a value. So if I just say 5 here, it will print between 1 and 5. And if I do 10, between 1 and 10, so on. So, and then if I want to send this information to a file, I could do a this T, and that file T is actually created that file T. And that for file T is the content of it is that. And if I say word count minus LT or cat minus NT, you can see it. And then grep minus I value from T, you can see that it picks it out from there. And then some of these variables and how you do it is all intuitive to it. And so, like, let's say, for example, I'm going to just show you set inside this file T. Let's just move the T to temp.txt. I'm gonna just cat temp.txt, which is the same file. I'm gonna do a vi improve on temp.txt. Now notice that there's spaces here. So I'm going to change all those spaces. I'm going to say line 1 through end of file, which is line 10 in this case. $sign means end of file. Substitute, and then I'm going to say 1 space to a colon. So if I want to just substitute every space there to a colon, this is how you do it inside Vim with the editor. So I'm going to save that one. Now notice that tim.text is just that information with values. Now if I do the awk by default, notice the difference. The awk minus by default, if I don't do it, the field separator is space. So if I say awk and then I say print $0, it still should give me a tim.text because I'm using no field separator, and then I'm just printing the entire file. So if I just say print $1 in this case, or just print this, it's still printed. But if I print $1, it doesn't know that $1 is the dot, because the field separator, it considered it as the entire thing as one line. So notice that if I do $2, it doesn't understand it. So in order for me to print $1, then I need to define the field separator like this, and then say field separator is colon rather than a space, and then do this. Now that is there. So if I go change to the word to, it is going to give me every field that I want. So let's just print $0 first and see how many column is there. That's 1, 2, 3, 4, 5, 6, 7. So if I just want the last one, then I need to do 7 here. And those one will be printed. And the equal sign is the field number 6. If you want all of them, you could just do $0 or print the statement itself. Similarly, watch the etc password file. So the etc password file are separated by colon also. Then I could say awk minus f, and then I could say, and this field separator is this, and then I say etc password, and then this time if I just say that is the file and I want to just do something with it, so I have to say for example the instruction that I'm going to print the pattern, I'm going to say print $0. That would just print everything on there. If I want to just say, for example, print $, let's say first one is the user ID, so I'm going to say print $1. You can see all the $1 is there. If $5 is the shell, let's say $5 is let's see which one is the shell. So I could do this command here and say, okay, this is field 1, 2, 3, 4, 5, 6, 7, and then what I could do is easily I could search for my user ID grep minus I wlitfy, and then wlitfy is, I can see that my shell is this is field 1, 2, 3, 4, 5, 6, 7. So my shell would be $signs. Was it 7 or 8? Let's see. 1, 2, 3, 4, 5, 6, 7. $7 would be the shell that you want to print there. And then if you're looking for only for user Wahid, for example, you could just say grep minus I wlitfy, and then bin bash. Bin bash is the actual there, so you have to do this grep stuff before that one to only pick up that user. So you say etc password, and then at this time and then pipe in actually you have to print the two variable, let's say $0, and then I'm going to do this $0 wlitfy. This would give me, but then I need to do awk of that one to print $bash only. So then I could just say awk and then print $7. First I picked up that user, now and $7. Let's see, 1, 2, 3, 4, 5, 6, 7. So let's see why 7 did not print it. awk print $. 0 is printing everything, and then this is 1, 2, 3, 4, 5, 6, 7. 7 should have been done, but let me just try 6, and none of them are going to come, I believe. Yeah, that 1 is coming. Oh, the other ones are all coming as again, and the field separator. So here, since I'm using the default one, the field separator is the space. And so in order for me to get the 7 like this, then I have to say the field separator in this case is the colon, because that is instruction, the way it is printed. So you have to have a space here, and then that would just print out. And if I want to just, let me just do this syntax first. And then this one, so the field separator in this case is 7. If I want to just get the home wlutfi is 6. And then that would also print home wlutfi. I could also get the ID wlutfi and then say, for example, echo $shell, and then echo $home to print out those as well. Get end password wlutfi also give you the information from the shell. All I'm showing you that you can do these commands with all command lines as well as this. So you could say, for example, ps minus efa grep minus I httpd, for example. And then you could say, well, I need to just shut down the Apache web server or kill it or start it, anything. You can just work on these processes as well. So you could say ps minus ef grep minus I httpd, and then awk, and then print and $2. In this case, I'm not going to do anything with it, but this is how you parse it. And then you could say while read var and do, and then say, for example, if you want to just kill it, you just say equal killing the process. And then I'm not going to do the actual kill, so you could just do a pound, which is not killing it, kill -9 and $var. And then that $var will actually be killed because I put the pound. It will not just kill it. So I could just say killing, but I don't want to kill it. So you could just show still as an example how somebody else would take care of their hanging process there. And then at this time, I'm going to just say, for example, just to show you that I did not kill it, I could just say grep minus grep $, and the process ID number, which is in this case is a var. I should have used PID rather than var. So here I'm just saying that I did not kill it when I just do that one. And then you can see that I listed all of them are still there. And then if I just go here, ps minus ef grep minus I http, you can see those processors still there. The previous example that I used here with awk, you could still get those numbers because I didn't do anything with it. So similarly, if you want to just use awk to just say cut star.bash, and then you say, okay, I'm going to get this one, but at the same time, I want to just parse and make a backup of these files that are there. I want to just change it, make a backup of it. So you can do this one with a find command easily, and you can do it with a while read. We could do it with awk. You can do it with set grep. Any way you want to do it with for statement, while statement. But let's just use an example of awk. So here's an example of awk. I'm going to just say for each of these files that I have, I want to first get a listing of the file name. So I say awk, and then I say print $9, and this would give me the file name. But at this time, I just don't need the extension .bash since I'm going to name it .bash, but I'm going to just give it something else. So I'm going to say cut -d, and the delimiter in this case is going to be just a dot, and then minus F1. So minus F1 give me the file name here. And then I could just say, now I'm going to say while read a var, and I'm going to say do, I'm going to say echo copying $var dot bash to $var dot. So I'm going to put this one $var dot bash to $var dot bash dot back for backup. So we just name it something dot bash dot back, and just in case we want to show it. Here I'm going to say the actual command, copy and $var, and then dot bash to $var dot bash dot back. So that would be doing it, and then ls minus ld, I'm going to just say I did the backup. So I will list both of the files here, saying that I just actually did it if it was successful. Then I just say, let's say sleep 1 second, and then done. So notice that it just gave me 1 second, then it just actually lists the 2 files that was being copied here. So now for every file that I have a dot back and a dot bash file. So now if I just go back to the same syntax here, that was these names, and then I just say, show me the one with the dot bash, dot back. Now it's all those one there. So now I can just use one find command, find minus name star dot bash dot back, and then this would just list those files here that I just made. If I do a minus exact ls minus l, and then give me a listing of them, so you can see that the files are listed as well. And this ls minus l, I could do semicolon, I mean slash semicolon or a plus, they would do the same thing. This other one is the loop of it, and just says that exact is saying that whatever is between this instruction, execute that command. And then this is find is saying that from the current directory minus name matching any file with this extension, and then provide me the list. So now it is there. I'm going to just say, go ahead, remove it. I don't need it. So now I removed it. If I just do this list, it's not going to list anything. It did not find anything with star.bash.back. Now it's not found. So that is good. We just have everything .bash, and we showed you the example, and we made a backup. We did not need the backup. We cleaned it up. So there's a lot of things you can do with awk, grep, set, egrep, and other ones. As we make progress on these videos, I'll just make a separate video for each of these sessions, but I don't want to just make each session too long, because somebody was asking if we could do some examples. So awk and set and other ones at the terminal session. I hope this one helped you, and I hope it will help a lot of other people's. If you're a system administrator and you're doing kind of a command line terminal session with online scripting and everything, awk, set, grep, and nawk, gawk, egrep, and fgrep, set, all of those ones are your friends. For statement, loop, paying with while and do and everything else. Just watch my videos on YouTube. There's a lot of advanced videos, as well as intermediate, as well as beginners. So please watch them, and you're welcome to look at them. And this is like Learn Linux on Advanced Operating System, level 4, part 8 of 8. It does a lot of details. And then I have done a lot of Python, C, C++, awk, set, Apache, everything that you could name of, like Unix, Linux, some C shell, some bash, some set, grep, and then process mapping, and proc file system, and then the scripting. It's a lot. So just go watch it, enjoy it. Have a good one. Take care. Bye-bye.